Unit 10, Day 2 homework tutorial. Day 2's homework consists of section 10.3 of your textbook, and it's the front side of this handout only. The front side of this handout only. So I will work with you on the odd problems to help you work on the evens. But again, your homework is the evens most likely, but I'll work on the odd problems and you just mimic the same material and concepts for the evens. For number 1 and 3, you're going to be using theorem 10.2, which says that the arcs and chords will have the same measurement. So, I'm sorry, if the chords are congruent, which is RS and TS, then the arcs are congruent, RS and TS. So we do know that this arc, RT, is 64, and that the total of an entire circle is 360. So if I take 360 and subtract 64, that'll leave us with the amount left over for the rest of the circle. And that amount should be 296. And if I take that 296 and divide it by 2, will tell us what each part is left over. And that would give us 148. So x is equal to 148. On number 3, again, it's using 10.2, which says if the chords are congruent, which they are, they're both equal to 4, then the arcs are congruent. So that means x is equal to 82. For number 5 and 7, we're using the same theorem, theorem 10.2, which says if the arcs are congruent, the chords are congruent, or if the chords are congruent, the arcs are congruent. So it is showing that the arcs are congruent, so that means the chords are congruent. In other words, that means that 2x plus 4 is equal to 18. So now we can solve for x by subtracting 4, which would give us 2x is equal to 14, and dividing by 2, x is equal to 7. On number 7, again, the two chords are congruent. Both of them are 6, so that means the arcs are equal. So that means 3x plus 2 is equal to 2x plus 4. That's a 4. And so subtract 2x from both sides would give you x plus 2 equals 4. Subtract 2 from both sides, which will give you x is equal to 2. On number 9 and number 9 is still using the same theorem, theorem 10.2, except for you see it on two different circles, but that's okay because 10.2 does work on two different circles. Also, it shows you 162 degrees and then 198 degrees on a different circle, but you have to ask yourself, does the other piece of the circle equal that amount? We'll simply subtract 162 from 360 and see what you get. You get 198. So if one part is 162, the other part has to be 198, and vice versa. So the other part on this circle is 162. So now it's showing that my arcs are congruent, so that means my chords are congruent. In other words, 9x minus 78 is equal to 3x. Subtract 9x from both sides, you get negative 78 is equal to negative 6x. And divide both sides by negative 6. You would get 14. So x is equal to 14. Not 14. Uh, hold on. I know that 12 times 6 is 72. So is this going to be a decimal? 13. That was one off. My bad. All right, on number 11, we're going to use theorem 10.5, which says that if the chords are congruent, the chords it's referring to are DC and CB. So if DC is congruent to CB, then their distance from the center is congruent. And they also mention that those are congruent. So great. So that means GQ is congruent to QE, which is this distance that the chord is from the center. So now that I know that, I can put x plus 5 equal to 3x minus 6 and solve for x. So I would subtract x from both sides, which would give you 5 is equal to 2x minus 6. Add 6 to both sides, which gives you 11 equals 2x. And divide by 2, so that's 5.5 equal to x. And number 12 through 17 involve using theorem 10.3, which states that the radius is, if the radius is perpendicular, it will bisect the chord and the arc. So it's showing that the radius is perpendicular, so that this chord gets broken into two equal parts, and this arc will also get broken into two equal parts. And you can take care of that on both circles in advance so that you don't forget. Now, it also mentions that the radius is 13, RS is 24, so that means each part is 12. And we're going to find PT. PT is this little tiny piece right here. So to find PT, what you would need to do is draw a line, draw another radius on the circle, preferably PR or PS. And you're going to use that right triangle to find PT. You know that, let me make it a little clearer and isolate the triangle. But this is essentially what's going on. P, T, S. TS is 12 because that's part of RS. PS represents the radius, so that's 13. So PS is what we, or sorry, PT is what we're looking for. So we use Pythagorean's theorem to find side B. And I told you the shortcut that B is equal to the square root of C squared minus A squared. So that's going to give you 5 if done correctly. So PT is 5. On number 15, to find arc DE, you're going to use the provided information that was given that the total arc CD is 90. That's all of that. And DE is half of 90, so half of 90 is 45 degrees. And last but not least, number 17, you're looking for AF, and AF is found just like I did for PT on the previous circle. So essentially, you're going to draw another radius. So you have a right triangle, and I'll isolate the right triangle so that you can see it. Sorry, that's F, A, and C. The radius is 6. FC is 4. So AF is B again. So B is equal to the square root of 6 squared minus 4 squared, which ended up being some decimal. Approximately 4.47. And since it said round to the nearest hundred, that is good enough. So AF is approximately 4.47. And this concludes your tutorial for this assignment. I hope this information was helpful. Now complete the evens.